In this lesson, we're going to talk about the basics of exponents. When we have exponents, it's just a case of repeated multiplication with the same number. We can rewrite the expression with exponents. For example, the repeated multiplication 4 times 4 times 4 can be rewritten as 4 to the third power. So when we take a look at the parts of the exponent, in that example, the 4, that bigger number, is called our base. And the superscript, the smaller number in our example, 3, that is called our exponent. And we can read this example here as x to the nth power. So we read our base first, raised to our exponent. So let's take a look at writing them in exponential expressions and finding their values. So if we take a look at number 1, 11 times 11, we can write that as an exponential expression by using 11 as our base because that's the number that is being multiplied, and we're multiplying it 2 times, so 2 is our exponent. So 11 squared, or 11 to the second power. Now we can find the value of this expression because we know that 11 times 11 is 121. Go ahead and yellow highlight number 2 and then look at number 3. So number 3 has a negative number that we're multiplying. And notice how that negative number is in parentheses. So when we rewrite that into our expression, we want to keep that base of negative 5 in the parentheses. And then we're multiplying negative 5 1, 2, 3, 4 times. So it would be negative 5 to the 4th power. And we can also evaluate this one and find the value. Negative 5 times negative 5 times negative 5 times negative 5 ends up being 625. Now, if you're using a calculator to calculate that, make sure that the negative 5 is in parentheses and your exponent of 4 is on the outside of your parentheses. Now, number 4, we have repeated addition with a fraction. So again, we're going to use parentheses for that fraction. So our base is 1/4. And then we're multiplying 1/4, 1, 2, 3 times. So our exponent would be 3. So 1/4 to the third power, or we can say 1/4 cubed. We can also evaluate this. When we're evaluating it, we want to evaluate our numerator and then our denominator. So 1 times 1 times 1 over 4 times 4 times 4. 1 times 1 times 1 is 1. 4 times 4 is 16, and 16 times 4 is 64. So this expression evaluated is 1 over 64. So that third power goes to our numerator and our denominator. Now in number 5, you can see we have 2 different numbers that we're multiplying. So I'm still repeating multiplication of my 7s, and I'm repeating multiplication of my 4s. So I can group together this repeated multiplication. So focusing on my 7s, my base is 7. And since I'm multiplying that 7 2 times, my exponent is 2. Times, to represent my next group, my base is 4. And then I'm multiplying that 4 3 times, so it'll be to the third. So I can also evaluate this. And we're going to use our calculators to evaluate this one. So if you'll put in your calculator 7 squared times 4 to the third, and you can put that all in one step, you should get 3,136. go ahead and yellow highlight 6 and 7. So remember to group together for 6 and 7, group together your like multiplication. Now number 8, we're dealing with variables. So it's still repeated multiplication, but what I'm multiplying here is an a, so a variable. So my base is going to be a. And then if I count how many times I'm multiplying a, that's 9 times. So a to the 9th. Now we can't find the value of this because we don't know what the value of a is. So we'll leave this value spot blank. For number 9, we could do the same thing. So we don't have to group number 9 like we did 6 and 7. The term that's being repeated multiplication is xy. That term stays together. So xy is my base. We're not going to separate that. So my base is xy. Then if I count how many times I'm multiplying that, that's going to be 5 times. Now I'm going to add something different here because the way it's written here is the y is being raised to the 5th power, but we need the whole term xy to the 5th power. So we're going to put parentheses around the xy. That's going to show that that exponent of 5 belongs with the x and the y, not just the y. And just like number 8, we cannot find the value, so we'll leave that one blank. So if you'll go ahead and yellow highlight 10, 11, 12, 13, and 14. And for all of those, remember, especially for number 10, you're not going to be able to find the value. Number 11, you will be able to find the value of your groups of 9. So you can actually multiply out the 9 times 9 times 9. But then the k will stay as an expression. The same thing on number 12. You can still find the value. Number 13, you won't be able to find the actual value. And then number 14, you will. So for 11, 12, and 14, you'll have a value for your numbers, but then you'll also have a variable in your answer. Another property of exponent is called a zero exponent. Any number except 0 raised to the 0 power is defined as 1. So basically any number other than 0 raised to the 0 power equals 1. So 1 to the 0 power equals 1. 2 to the 0 power equals 1. 3 to the 0 power equals 1. 4 to the 0 power equals 1. X to the 0 power equals 1. The only time this is not true is when it is 0. So your base cannot be 0 for this to be true. Now the last thing we're going to look at with exponents in this lesson is if we have a negative exponent. So you can see in this example, I have x to the negative n power. You never want to have an exponent in your final answer that is negative. So our rule for negative exponents means we just need to do basically the reciprocal. So remember, we can write any whole number over 1. And the reciprocal means we flip it. So when we flip this, it's going to be 1 over x. What happens to that exponent is when we flip it, it becomes positive. So if you have a negative exponent, when you flip that exponent, or when you flip it, it's going to become positive. The base will stay the same, the exponent just changes. So when we look at number 15, 5 to the negative 2. Again, with a whole number, we can put that over 1. When we flip it, that's 1 over 5. That negative 2 is now a positive 2. And then we can evaluate that further because we know what 5 squared is. 5 squared is 5 times 5, which is 1 over 25. So when it's evaluated completely, it's 1 over 25. Go ahead and yellow highlight number 16, 17, 18, 19, and 20. And remember, once you flip it to make that exponent positive, you can then evaluate it. Number 21. I have two exponent expressions with two different bases. Both of those expressions have a negative exponent. So we're going to have to flip both of those. So both of these are over 1. When I rewrite that, that's 1 over 4 to the now positive 3 times 1 over 7 to the positive 1. And we can evaluate that. So 4 to the third power is 4 times 4 times 4, which is 64, times 1 over 7 to the first power is 7. So we need to multiply 1 over 64 times 1 over 7. We multiply straight across. 1 times 1 is 1. And then 64 times 7, you can work it out on the side of your paper, or you can put that into the calculator. And you get 448 for our final answer. So you want to make sure you don't have any negative exponents, and we do that by doing the reciprocal. Once you don't have any negative exponents, then you can actually find the value by solving that exponent and then multiplying straight across. So following through with that problem. If you will yellow highlight 22 and 23, let's look at 24. So in 24, I have 3 different exponent expressions. Only one of them has a negative exponent. That's the only one that we're going to have to flip. So if we put that 8 over 1, that would become 1 over 8 to the positive 3 times 10 squared. I'm going to go ahead and put it over 1 so that we have all of our fractions, times 4 to the 0 over 1. So now we're going to evaluate all of these exponent expressions. So 8 to the third is 8 times 8 times 8. So that would be 1 over, again, you can work it out on the side of your paper, use your calculator. That would be 1 over 512. So 8 times 8 times 8 is 512. Times, so now we're looking at this second piece here. So that's 10 squared, 10 times 10, that's 100 over 1, times this last piece here. Remember, that's going to be our 0 rule. So anything to the 0 power is 1. So 4 to the 0 power is 1 over 1. And then we can multiply straight across. So 1 times 100 times 1 is 100. 512 times 1 is 512. And we can all agree that this is not going to simplify, or it's not going to divide evenly, but we need to always simplify. So 4 will divide evenly into both of these. So it will simplify all the way down to 25 over 128 for our final answer. Now, if we have exponents as our base, we do the same thing. If our exponent is negative, we're going to put it over 1, and then we're going to flip it. So 1 over x to the, now it's a positive 9 since we flipped it. But when we have variables, we leave our answer here because we can't actually multiply out x to the 9th power. Go ahead and yellow highlight number 26, 27, and let's look at number 28. So on number 28, 2 of my exponents are negatives. So those are the only 2 I'm going to be worried about flipping. So if I were to rewrite this, it would be 1 over 3 to the third times 1 over m to the 4th times n to the 5th over 1. So the n to the 5th is going to stay in our denominator. We just put it over 1 so we have all fractions. So when I multiply straight across in my numerator, that's going to stay n to the 5th because we can't multiply n to the 5th out. In my denominator, I can multiply 3 to the 3rd. That's 3 times 3 times 3. That's 27. And then m to the 4th, I can't multiply it out, so it's going to just say m to the 4th. So our final expression, or our final answer, is going to be this expression.